This is Ziad Ali again with a new problem-solving session on loops. This time we are going to solve 20 plus problems using different types of loops. Before I start, I need to say that mastering loops is a core skill for any successful developer. Regardless of the programming language or platform you are working with. Mastering loops is a key and core skill. It can help you become more productive and efficient in your work. Let us get started, and we are going to start with counter-controlled loops. Counter-controlled loops are a type of loop in which the number of iterations is known or at least can be determined in advance. In other words, we can use the counter variable to keep track of the number of times the loop has been executed and use this variable to control how many times the loop should be executed. We know in advance, before we go inside the loop, how many iterations are needed. Let us see the first example. Our first example is going to be sum and average of 5 numbers input by the user. So the question says, write a Python program that uses for loop to find the sum of 5 numbers entered by the user. So this problem needs us to use for loop. And we know how many times the user is going to input the value. And we need to find the sum. Average is simple. After the loop, we can divide the sum by 5. So let's see how would we do this using some kind of pseudocode. First, you need to initialize some kind of sum to 0, and this should be done before the loop. Then your loop will go 5 times. So using a for loop, the question says using for loop for I in, this is I, in range 5. It will be from 0 to 4, and this is 5 times. Now inside the loop, we will use a temporary variable or some kind of a bucket to take the value from the user and add it to sum. Let me say here inside the loop, I would say value is equal to float input. And once the user input this, I need to take this value and add it to sum. So initially sum is 0. And after the first time the user inputs the loop, we will say sum is equal to sum plus value. So let us say the user input 5. So here after this statement, sum will be 5. The loop will go 5 times. And every time you enter a new value, it will be accumulated, added to sum. Let us say next time you enter 10, sum will be 15. Then you entered 20, sum will be 35, and so on. After the loop, you can print the sum, and you can also divide by 5 to get the average. Now let's see this in code. First step, sum is equal to 0. Then a for loop for I in range 5. Value is equal to float input, enter a value. And this is going to happen 5 times. Then we take the value input by the user and add it to sum. That's it. Outside the loop, once we finish, we print sum. Let's say sum is equal to, comma, sum. And also we can say AVG is equal sum divided by 5. Then print average, comma, AVG. That's it. Let us test our code now. Run. Here they say enter a value. I'll enter 9. We are now at line 3 of our code. 9 will be stored inside value. In line 4, 9 will be added to sum. The step is again repeated. Now I add 10 to sum. 4, 3. Once the loop is done, I go outside the loop. They tell me the sum is 30 and average is 6. That's it. In the second part, they say rewrite the same code using while loop. I will do the code in the same program and then separate it into 2 programs. Let's see. I'll come here and say sum 1 is equal to 0. If you use a while loop, you need to define the counter outside the loop. Let's say I is equal to 1 or 0. You can do whatever you want. If you do 1, you make sure you go inside the loop 5 times. How you do this? While I is less than or equal to 5. This time 5 is part of the loop. You are starting from 1 to 5. Again, I'll take the same code, copy paste. The same code here. And I say value is equal to input. Sum 1, another variable here, a plus value. That's it. One thing is missing here. You need to increment manually the counter. I is equal to I plus 1. That's it. This is the end of our loop. I'll take the same code I wrote before here and paste it after the loop. I need to change the name of variables maybe. AVG1 instead of average and sum1. That's it. Now I'll comment the top loop here, control /. So only the code starting from line 9 is going to be working. I'll clear the screen and run again. Enter a value. I am at line 12 now of my code. 9, 5, 6, 8, 7, whatever. So the same result and same code was achieved. Remember, I started from 1. Then I need to stop at 5. 5 will be used here, not like for loop here because I started from 0. Take a value, add it to accumulator, increment the counter. This step is done automatically to you in the for loop, but in while loop you need to do it manually. Printing sums, averages, and all these results is not going to be done inside the loop after you finish the loop. Now we do the same problem, but this time for n numbers, not 5 numbers. This time the user is going to decide how many values we are going to input. It's a simple change. We just need to modify the question by asking the user before the loop how many values. And this is going to be another variable in our code. I'll again modify the old code to show you the differences. Here I go and comment the while loop code and decomment the for loop. Now I'm not going to say 5. I will ask the user here, for example, n is equal to integer input how many values. That's it. And my loop now will go for I in range n. And my average will be divided by n. صحيح إنه الuser entered the value here before the loop, but this is still a counter-controlled loop because I know how many iterations are going to take place before I go inside the loop. Let us run this program now. Let me clear first here. Run the program. How many values? I forgot S. 3 values. Whatever values I enter here. And now I get sum and the average. Clear? And comment this. Decomment the while loop. I'll do it again with while loop. I'll take the same code here, N. And the only change is going to happen here while I is less than or equal to N equal to, and sum here I will be dividing by N. So this time we ask the user how many values. Let me run here. I have 5 values, then enter first value, second value, third value, whatever value you have. It's a good idea to also tell the user which value you are expecting from him by telling him enter value 1, 2, 3. Here, for example, look at this one. In line 14, I would say F, which is string format, enter value I. Enter value I is going to tell the user enter value 1, value 2, value 3, because I will be 1, 2, 3, 4. Let me run the code without clearing the screen. How many values? 5. Enter value 1. Maybe I need a space here. Control C, stop the code. Clear. I'll just need a space here between value and 1. Run here again. I have 5 values here in the first one here. 5 values. Enter value 1. That's what I was looking for. I keep entering the values, so I know which value I am entering. So I'll comment this and go back to the for loop, try to do the same change. Remember, in for loop, you start from 0. Of course, you can start from 1 to n plus 1. And this is a basic thing that should have been covered before. You can come here and do the same thing and say value of I. Hopefully we get this, right? Clear? Run. How many values? 3 values. Enter value 1, good, 2, 3. Excellent. If you start from 0, like for range in I1, you just make it I plus 1. You are not changing I here. You are not making any changes. Only the output is better than telling the user enter value 0, which makes no sense to users. You need to say enter value 1. Run. So here, how many values? I have 5. Okay, by adding 1 to the variable I get a good prompt message. I don't think this is the end of the question. Let us see what else they want us to do. In the second part of the question, they need us to modify the last program, and they need average. We already did average, very simple, but this time they need max. Max value of all the 5. So how to do or how to find the maximum value for a list of values? This question can be solved in many different ways, but in Python there is an easy way to do it. We will assume before the loop, maximum value is equal to float, and now there is some kind of unique thing to do, which is minus infinity. That's it. This is our first thing to do. Minus infinity is the smallest value that can be represented using Python. There is no smaller than this. Okay, what's the use of this inside the loop? Let me show you. Once you enter a value, you will compare it with max. Max value in line 3 is the smallest value ever. You cannot enter smaller than that. Here, inside the loop, you would compare your value with max. If your value is larger, then you swap them. You say max is equal to value. How this is going to work? Let's see. Imagine if you entered 5 here, first time. 5 is larger than max, which is minus infinity. Then max value will be equal to 5. That's it. You come back. Next time you enter 3. It will be compared. Is 3 greater than max? No. Then nothing's going to happen. Next time you enter 15. 15 is larger. I'll show you this using the bugging. So after the loop, I would say max, print, max, value is and comma max. I like to show you how this program is going to work by adding some breakpoints here on the important points here. Okay, let's see this. I'll debug my program so you'll be able to see the contents of each variable used in this code. In this area here, you can see now sum is 0, n is, I can continue here by telling just go ahead, continue. How many values? I'll say, for example, 5 values, enter. And here, as you see, number or n is 5, sum is 0. Now max is equal to float infinity. We are not going to input anything, it's given to it. And see, it's represented like minus infinity. So now we go inside the loop. First time, they want me to enter a value. I'm just clicking on the continue. I enter 7. Look at the comparison now, what's going to happen. By entering 7, so value is 7, max is equal to minus infinity. Comparison is going to happen now on line 7. So let me go click on this. Click again. So max will be changed to the value of 7. Look at the change here. Max is equal to 7. Continue. I go again inside the loop. They ask me for another value. This time I'm going to enter 3. 3 is not greater than the current max, which is 7. So the if statement will return false and nothing is going to happen. One more time now. I'm entering a new value. Here is going to be 9, which is greater than 7. So max will be given the value of 9. At the end, the largest value you enter will be stored inside max. Run again. I keep running it. Now I enter, for example, 99, this value. And this value is definitely greater than max. See now, at line 7, max will be changed to the value 9999. Last time, I will enter a small value. Okay, just 2. Input. The if statement will return false. The max value will remain 9999, and that's it. We are outside the loop now. Sum will be printed, as you see. Average will be printed. Both are easy. And now max value is 4 9s as we did that before. I'll stop debugging. And now do the same thing using what? Using while loop. Decomment it. I'll just need to take the max here. And I believe everything is going to be the same. Look, I'm just going to take this if and use it here. Make sure I do not copy wrong things here. Indentation should be good. بس خلاص, that's it. So while n, and finally I can also copy paste the same code here. Okay, running the same program with while loop here. I have 5 values. I'll enter any random values. You can keep an eye on their values. The last one is not the largest, so max is 222, which is fine, and that's it. So we did three different problems using both while and for loop, average, max, and so on. If you want minimum is the opposite. I can do minimum here, and I can say float infinity. I will say minimum is equal to the largest ever value that can be represented using a computer. I can compare this one to minimum by saying if it's less than minimum, then minimum is equal to value. Change all the output now here, and let me explain it to you quickly once the code is done. I will say minimum value is equal to infinity. Then definitely any value you enter is going to be smaller than that. We will be playing with the value minimum. The lowest value will finally be stored in the minimum value and we print it. Let me clear and run here. Run my program here. How many values I have? 5. Enter value 1, 9. Now I am at line 19. Line 20 will add it to sum. Line 21 will compare 9 with infinity. Is 9 less than infinity? Yes. So minimum will be equal to 9. That's it. And now I go and enter 2. 2 will be given and compared again at line 21. Is 2 less than 9? Yes. Then minimum will be 2. Now I'm entering 88. In this time, line 20 or 21, the value will be false. 1 will be the lowest value. 8, whatever. So the minimum value is 1 here. So you do the opposite with minimum. Assume minimum is infinity, then compare the value. If it's less than that, you place it in the minimum. And you keep comparing the values until you finish. Once you finish, you will find out that the lowest values are stored inside minimum. Now we go to another type of loops. In this type, you don't know in advance how many times you need to go inside the loop. These loops are called Sentinel-controlled loops. Sentinel-controlled loops are a type of loop in which the loop continues until a specific input value is entered. This value is known as Sentinel value. In other words, we use a special input value to indicate the end of the loop, rather than relying on a predetermined number of iterations. Let's see the first example. Again, we will do the same example we did before with counter-controlled loops. But this time, we don't know how many times or how many values are going to be entered by the user. The question says, using while loop, write a Python program that keeps reading numbers from the user until the Sentinel value -999 is entered. Print the sum and do not use while true break loops. So we will keep reading values from the user until -999 is entered. So in this case, clearly, we don't know how many values are going to be entered. The question says, find the average. Fine, we will do it. And get the maximum and minimum. We have done that already before, but this time maybe we need to keep track of some other things. Let's see how this program or this loop can be solved. First, you need sum. As usual, sum is equal to 0, initialized before the loop. Now is the new thing for this type of loops. Take one value before the loop. So here we say value is equal to float something. We have taken a value before the loop. But look at the next step, which is the loop condition. While value is not equal to minus 999. This means the loop condition becomes false the moment you enter minus 999. Continue inside the loop now. If you go inside the loop, it means the value you entered is not minus 999. So we will use it and add it to sum. Done with processing the value here, which is only finding sum. In the last step of the loop, request the next value again. You can copy paste the same code you did before. Values equal to float input. And it's a good idea to tell the user to enter a specific Sentinel value if he wants to quit. That's it. Let's repeat the steps quickly. Initialize sum to 0. Take one value before the loop. Loop condition remains true unless the Sentinel value is entered. Process the value in the loop. Process may be one step, maybe 1 million steps. In the last step of the loop, request the next value. So if we enter here first time, if you enter 10, this condition will be true. Value is not equal to minus 999. So 10 will be added to sum, and sum will be 10. And it will go to the next step and request the next value. The next value is not going to be used before it's checked again. So you will go back to the top of the loop, and the new value is checked. Is it minus 999? No. So you go inside the loop again. You add it to sum. And you keep doing this until you enter here, for example, at one moment you enter minus 999. We don't know if you're going to do this after 5 values or after 50 values or any number of values. That's why we don't know how many iterations, but this loop works. The moment you enter minus 999, the value is taken back to this line here. The loop continuation condition becomes false, and you go to the step right after the loop, which is print sum. In short, take one value before the loop, design the loop condition to become false once the Sentinel value is entered, process the value, request the next value in the last step of the loop. That's it. Let's do it in code. Sum is equal to 0. Take a value before the loop value is equal to float input. Enter a value. And it's a good idea to say minus 999 to quit, or whatever value. We did the first part. Take one value before the loop. Design the loop condition. Let me correct this. Now design the loop condition to remain true unless the user inputs the Sentinel value. So it's going to be while value is not equal to minus 999. That's it. Process it. Process it now is very simple. Just add the value to sum. Sum plus equal value. In the last step of the loop, request the next value. So one value only before the loop. Design the condition to become false. Use the value, request the next value in the last step of the loop. Print sum. Let's run this quickly. Run. Now I am at line 1, requesting the value before the loop. I'll enter 8. 8 will be taken. In line 3, the continuation condition remains true, so it will go inside the loop, add 8 to sum in line 4, and jumps to line 5, stops request the next value. I am now at line 5. I enter a new value. I keep entering values. Nothing is going to happen. They will keep accumulating the values until I enter now -999. Now I am at line 5, entering -999. It will not be used. It will be checked first. The value will be taken to line 3, and the condition becomes false, and it will go to line 6 and print the sum. That's it. The question said, find the average. In the previous examples, we knew the number of values before we go inside the loop, but this time we don't know. So we need to also initialize some kind of a counter. Let me call it count is equal to 0. This count will be incremented by 1 every time you go inside the loop, because you never go inside the loop unless the value is valid. So now if you go inside the loop 5 times, this count will be 5. Let's quickly do this and see how many values entered. Print count after the loop. Run. Okay, I entered 1 value, 2 values, 3 values, and now I'm entering -999. So count is 3. Excellent. So in order to find the average, just say average is equal count, sum divided by count. And print the average. Let's see this one last time. Clear. Run. I'll enter quickly some values here. Okay, now I'm entering the Sentinel value. I get the total, the count, and the average. One thing here. What happens if you enter -999 in the beginning, first time? Let's do it. Run. I'm still at line 3. If you enter -999 now, it means you don't want to continue. So it will skip the loop because the continuation condition becomes false. Of course, my program is going to generate an error. Let's see the error. The program said sum 0, but here we have some kind of division by 0. Why we get this problem or exception? Because count is 0 and sum is 0, and in line 10, you are trying to divide 0 by 0, which is invalid value. How to fix this? You can come here and say if count after the loop is greater than 0. If count is greater than 0, then you do all these steps. If count is greater than 0, it means you entered some valid values. And here you come say else. Else means you entered 0 values. So you can tell the user why you are not entering count, for example, here, valid values entered. That's it. So now you avoid this exception and your program remains working and the user would know what happened. Run. I'm going to enter -99 in the first time. So I get this message, 0 valid values entered. Let me run it again with some good values. 9, 45, whatever values here I'm entering. Okay, now I am done, -999, and as you see here, 6 values entered, total is this much, and average is this much. I can come here and give some good messages, some like this. And here I can say, count values accepted. Run again, clear first, Run again. I enter 1, 2, 3, some values. Enter -999. Sum is this much. 6 values accepted. And average is equal to that much. So, in short, take one value before the loop, design the loop condition to become false if the sentinel value is entered, process the value, and in the very last step of your loop, request the next value. After the loop, you check the number of accepted values and process according to the question. The question also needed us to find the maximum and minimum values. We will use exactly the same thing we did before. We will use in Python infinity, negative infinity, and infinity. Let's see this in code. Before the loop, I'll say maximum is equal to float minus infinity. And minimum is equal to float infinity value. So now inside the loop, I will be doing two things. I'll try to find the maximum and the minimum. So the value you enter, I'll compare it with max. So if your number, if value is greater than max, then max is equal to value. So if you enter 10 first time, 10 will be the new max. If you enter 50, 50 later will be the new max. For minimum, we'll do the opposite. If value is less than minimum, so minimum is equal to value. And by the way, that's it. I can come here after the end of the loop, print max and minimum, and let's test it. Finish this. Good. Clear. Run again. Entered 9, whatever values I'm entering. You can keep track of the values, which one is the largest. I'll enter -5. And now I'm done. I'll enter the sentinel value. Sum is that much, 8 values accepted. Average is this much. Maximum is correct and minimum is correct. So to find max and minimum, use float infinity and float minus infinity. Compare your values and switch the value if the current value is lower or higher than the one, depending if you are calculating maximum or minimum. We are done now with the Sentinel-controlled loop example. We'll see another example. The second example asks us to do again the same thing, but using a while true loop. So what's a while true loop? A loop that remains true forever. However, you can break out of the loop if something happens. Here in the question, they say use while true and break loop. Or using while true and break loop, write a Python program that keeps reading numbers from the user until the sentinel value -99 is entered. Print the sum. Let me give you an idea about this. We will initialize sum to 0, as usual. But look now at the loop condition. While true. While true means forever. This loop will run forever, which is wrong, unless you have a plan to break out of the loop in a certain condition. Take the value inside the loop. Now check the value. If the value is -999, break. If it's not, you continue. That's it. And one more time. While true means forever. Take a value. Good. Then check the value before you use it. Don't use it unless it's checked. So here we say if value is equal to minus 999, break out of the loop. If it's not, the loop continues and keeps requesting values. So this loop will only be terminated if you enter minus 999. This is called the while true break loop. No need for the techniques we use in the Sentinel loop. However, break is not considered the best way to write loops. In all textbooks, you usually find some kind of a recommendation that break and continue are not really recommended to be used extensively. But this is still one valid and popular way of writing loops. Let's do this quickly in code. It will not take time. Okay, as usual, we say sum is equal to 0 and while true. True with capital T in Python. That's it. Value is equal to float input. Enter a value. You can say minus 9992. Exit. Now, this is the most important step in this type of loops. If value is equal minus 999, break. That's it. Otherwise, the loop will continue and value will be added to sum. After the loop, you can print the sum. Run. Enter a value. I am in line 3. Nothing was checked before the loop. The loop will continue. I keep entering the values. Now I'm entering minus 999. I am in line 3 again. It will be checked. The if statement will return false and break will be used and the program will jump to line 7. Of course, if you want average, you just again initialize a counter. Don't increment the counter before this step. You must increment it after you make sure the value is valid, is not a sentinel. So now we know the counter. Maximum and minimum, again, max is equal to float minus infinity. And minimum is equal to float infinity. You do the same thing, but again, after you check the value. If value is greater than max, then max is equal to value. The opposite way with minimum. If minimum is less than, if value is less than minimum, then minimum is equal to value. After the loop, you can print now all the results. I'll copy paste them from here, from this program, with also checking the number of values before I finish the loop. Hopefully this code is going to work. I don't think it's not. So the new thing here, while true, take the value. Do not do anything before the loop. If the value is the one you want to quit, just use break. Break will take you here from line 8 to line 15. Do not use the value or increment the counter or do comparisons before checking the value, because if it's a sentinel value, then it's not one of the valid inputs you are expecting. Run. Enter a value 1, 2, 3, 4, 9, 8, 7, and now we go to minus 999. Sum is this much, 7 values accepted, average is that much, maximum and minimum all correct values. So this is a while true break loop. Nice and quick and still very popular. The third technique, when you don't know the number of iterations, is called yes/no. Yes/no is to ask the user a question after each value. Do you want to continue? Yes or no? If he inputs anything other than yes, then the loop terminates. Let's see the technique or the mechanism of such loops. First thing, you initialize sum to 0, but now there is a new thing with initialization. You will find some value or variable, call it and give it the initial value y, like yes. Give it any name. It does not have to be again. Sum is 0, we know that. Look at the loop condition now. While again is equal to capital Y or again is equal to small y. Why we do this? In case you input capital or small y, the loop remains true. We will see this in code. Take one value, use it, increment counter, find minimum, max, whatever you want to do. And at the last step of the loop, you ask the user again, input yes or no. If the user inputs y here, the loop condition in line 3 or in line here will be true, so it will continue. He inputs again yes again, and so the condition remains true. So this loop continues as long as you don't input anything other than the letter y. But remember, this type of loop is going to ask you after every input. Some people do not like it for this type of examples. Maybe it's fine for longer examples where you need to enter many things for one iteration. But in general, the idea here, you set a value again to y. The loop continues as long as again is equal to small or capital Y. Take one value, process it, ask the question again. If the user inputs y again, then the loop continues. If the user inputs any other thing, the loop stops. Let's see this in the code. Again, we start by setting sum to 0, but this time we have again is equal to small or capital Y, it doesn't matter. Your loop condition, while again is equal capital Y, I'll keep it capital Y and show you what happens here. I'll copy paste some code from older programs, the one I just did. And look at this. I think most of it is reusable. Values equal to, okay, no need for this. I will increment the count and do the sum. Let me initialize count to 0. Okay. I need infinity and minimum and maximum, which is good to find the code to copy always. Okay. So now, the only new thing, while again is equal to y, but again you have something to do at the last step, which is ask the user, again, this time is text, input a message like continue, for example, here. It can be any message, any value. Yes, no, that's it. I think I also can use all these things here. I think I can. I don't see any problem. Look at the code here now. The only new thing that this code will ask the user, continue yes or no after every time you input. Let us run it and please pay attention to this part. Enter a value. I am at line 7 now. So because I go inside the loop, I'll enter 7. See what happens now. They are asking me, continue yes or no. I'll enter capital Y. When I enter capital Y, the condition remains true. I enter another value. If you do not enter capital Y, the condition becomes false. See, now I'm entering small y. So the loop terminated. That's why if you want both of them, you can say, or again is equal to y. So this time, if I run my program, it doesn't matter how I enter y. But remember, every time you need to enter. Okay, sometimes you make mistakes here because you are expecting yourself to keep entering only values, not yes or y. So now I'm entering my last value here. I'll enter n. N in line 14 will be stored in again, and the condition in line 6 becomes false. So the loop will be terminated and execution jumps to line 15, and I believe we know what happens in line 15. Let me press enter. That's it. So we have seen three different types of loops. Sentinel-controlled without using while true, then while true and break, and finally, yes-no loops where you ask the user every time after taking one input, do you want to continue, yes or no? Now we covered all the three types of loops. Let's see some examples. The first one will be divisors of a number. Print all the divisors of an integer. To make a long story short, if you enter 8, the divisors are 1, 2, 4, 8. So you see which values from 1 to n are factors of n. Let's see some pseudocode here. You input a value. Let's see which loop is best here. I believe for loop is easy. You start from 1 to n plus 1. You know why n plus 1? Because you need n to be included. So now what's going to happen? You will divide n, or you will modulus n by I. If the remainder is 0, it means I is a divisor of n. So if n, first time n is I is 1, so definitely this will be true. It will print I, which is the divisor. Let us say you entered 10. It will come back. Second time, I is 2. 10 modulus 2 is 0. So again, 1, 2 will be printed. Third time, I is 3. The modulus is not going to return 0, so this statement will be skipped. That's it. Let's see the code. So let's get n from the user first. Do a for loop for I in range 1 to n plus 1. If n modulus I is equal 0, print I. Let us avoid a new line here. The question says print them next to each other. That's it. Let's do clear and run. Let me enter 9 here. Now I enter 9. N is 9. I will be 1 to 9. First time 9 modulus 1. It will be true. Second time 2. It will be false. Third time 3. It will be true. Let's see the output now. 1, 3, 9. That's it. Let's run it again with an even number. 20. 1, 2, 4, 5, 10, 20. That's it. The question said, find the number of divisors also. So that's very simple. Initialize a counter to 0. If this is true, just increment the counter. After the loop, you print count divisors found for n, which is the value. Let's run this again. Run. Enter a value 12. Okay. 6 divisors found for 12. So what's needed here? Why this statement was printed on the same line? Because the print did not give me a new line. So a good idea, after the loop, you just output an empty line. Let us run it with another one. 19, which is a prime number. So 1 and 19. 2 divisors found for 19. Excellent. And if I enter 88, I get this much. One more thing. If the question insists that n must be a non-negative value, then you need to validate it using a while loop. While n is less than 0, so you will tell the user input the value again. Here, for example, error, enter the value again. You can tell him any message. So this one here, this while loop will not be used unless you input a negative value in line 1. And you will never reach line 4 unless n is a non-negative value. Amazing way for validation using while loop. Let's clear and run the final version of this code. Let me enter a negative value, -9. So I'm inside the while loop now. Validation loop, -3. You will never be able to reach the next step unless you input a valid non-negative value. I'll enter 99 now. And these are the divisors of 99, 6 divisors. A second example, which is a popular example, and many students hate it, which is a prime number. You need to tell us if a number or an integer is a prime number or not. A prime number is a positive integer that's greater than 1, that has no positive integer divisors other than 1 and itself. For example, 11 is a prime number. You can only divide it by 1 and 11. In other words, a prime number is a number that can only be divided by 1 and itself. So before we write the code, problem solving here is more important than writing the code. Understanding the problem is the problem of many students. Let's see this. You enter a number, and we need to check the number if it's negative or not. We will do this in the code. However, now, see in line 2, we assume the number is prime. We use a variable, call it prime, and then we say the number is prime. Prime is equal to true. How come we do this? Let us see how we're gonna find out in the loop if the number is prime or not. For I in range 2 to n, why 2? Because all numbers are divisible by 1. Why n, not n plus 1? Because all numbers are divisible by themselves. So we can go from 2 to n. Now what we're gonna do inside the loop? Check. If n is divisible by I, then the number is not prime. How we do this? If n is divisible by I, see what we're gonna do. We're gonna do 2 steps, not 1. 2 important steps. Both of them must be done inside the if statement. We will say prime is equal to false and break. So what's this? If n is found to be divisible by any value, then the n is not a prime number. So we set the variable prime, the Boolean variable prime, to false. And we break. That's it. No need to do anything else after this. Because if a number is divisible in any one value other than 1 and itself, then it's not a prime. No need to continue the loop. So let's say you entered 9. 9 will be checked first if it's divisible by 2. And the answer will be no, it's not divisible by 2. Then this one will be false. It will be skipped. It will come here and check if 9 is divisible by 3. The value will be divisible by 3. And this will be true. 9 is not a prime number. So we set prime to false and no need to continue. We use break. Break must be left indented in the code. If you enter 11, what's going to happen? 11 is a prime number. This loop will always return false from 2 to 10. 11 will not return 0 if it's modulus here, if you use 11 modulus I. 2, 3, 4, none of them will be true. So, after you finish the loop, with 11, prime remains what? True. Because you will never execute this line. prime remains what? True here. So even after the loop, the value is prime is true. But that wasn't the case with 9, because 9 was found to be divisible on 3. So the value of prime was changed to false. So what's the use of this after the loop then? Look at the statement after the loop. If prime is equal, by the way, to if prime is equal to true, print n is a prime number, else print n is not a prime number. So if you come out of the loop and prime is still true, it means your number has not been found divisible by any other value other than 1 and itself. And if you come outside the loop with prime not true, it means your value is not a prime number. And this is how to find if a number is prime or not. Why to use break here? No need to continue if the number is divisible by any value, because that's it. The number is not a prime, no need to continue. Sometimes you have very large values, no need to continue. Let's see the code. I'll start from here, and I need to check the number is non-negative and all these things. Now let me say prime is equal to true. True is capital T. That's it. The loop will be for I in range 2 to n. Not 1, 2. 2, n. That's it. Then, if n modulus I is equal 0, then the value you entered is not a prime. We need to change it to false. And no need to continue. We need to break. That's it. This is the loop of a prime number. Here. The first part is validation, and here is the input. So what to do after the loop? After the loop, check the value if prime. You can say if prime without anything else, because prime is a Boolean type, or you can say prime is equal to true, like this. Both are the same. You can say prime n is a prime number. Why? Because if prime remained true during the life cycle of the loop, then the number is prime. Otherwise, the number is not. So here you can say else, and copy paste the statement. And here you can add the message not. Proper indentation, clear run. Okay, I'll enter a prime number first. 11. So 11, the loop will go from 2 to 10. This will never be found true. So prime will, after the loop, prime remains true and the value will be prime. 11 is a prime number. Let's try 9. 9 is not a prime number because at one stage, when you divide by 3, here, and why we do that? Let's print a message here. Print n is, look at this message, nice, is divisible by I. So we know why it's not a prime. Run. Again, run the same thing with 9. Sorry, here. 9. 9 is divisible by 3, and 9 is not a prime number. Let's try 11. With 11, you will not see any message because you will never go inside the if statement. And this is a prime number story.